We, the group of Srinivas, Prasanna, Sadek, and Zuhair, are going to discuss about the accelerating big data analytics with Apache Spark and HDFS cluster scaling. So let's see the table of contents. Introduction and aim by Sadek, HDFS and Spark architecture by Srinivas, the algorithm and dataset by Prasanna, executing the unified engine by Zuhair. So let's see the introduction and aim. In our data driven world, the efficient processing and analysis of large datasets have become increasingly vital. Apache Hadoop distributed file system and Apache Spark have emerged as popular solutions offering scalability, speed, and fault tolerance. Today, we present our exploration of these technologies through the development of a Spark application that implements the widely used word count algorithm on a massive file stored in HDFS. Our project aims to implement a Spark application that can effectively process a large file stored in HDFS. By doing so, we seek to analyze the application's performance, particularly in handling the challenges commonly associated with big data processing, such as scalability, speed, and fault tolerance. Leveraging the benefits of HDFS, including data locality and harnessing Spark's processing power, our project strives to provide a scalable and fault tolerant solution for processing large datasets.
So coming to Hadoop distributive file system architecture. So HDFS and Apache Spark are two widely used big data processing tools that work together to provide a powerful distributed computing framework for a variety of data intensive applications, including the word count algorithm. Some of the benefits of using HDFS as a distributed file system for Spark based algorithms like word count can provide numerous benefits, including scalability, fault tolerance, data locality, compactability, and cost effectiveness. HDFS is a distributed file system designed to store large datasets across multiple nodes in a cluster. This allows data to be processed in a parallel, which means that the workload is divided among multiple nodes, and each node works on a smaller piece of data. As a result, the algorithm can process the data much faster than if it were processed sequentially on a single machine. Additionally, HDFS provides fault tolerance capabilities, which ensures that data is replicated across multiple nodes in the cluster. In case one or more nodes fail, the data is still accessible from other nodes, and the processing can continue without any interruption. This means that HDFS can handle node failures without losing any data or disrupting the processing of algorithm. So coming to the Spark architecture. The Spark architecture uses the map reduce paradigm to process enormous amounts of data in a distributed environment. In this architecture, data is first divided into multiple partitions that are distributed across the nodes in a cluster. During the mapping phase, the data is transformed into a format that is more suitable for analysis by applying a mapping function to each partition. In Spark, this is done through a transformation called map, which applies the mapping function to each element in a dataset. The intermediate results of the mapping phase are then passed to the reducing phase, where the data is aggregated and summarized. This is done through a transformation called reduce, which combines the intermediate results from the mapping phase to generate a final output. In Spark, the reduce phase is often carried out using a variety of functions such as reduce by key or aggregate by key, which enables efficient aggregation of data based on the specific keys. So, let us have a conclusion on Spark on top of HDFS. In summary, the combination of Spark and HDFS offers an excellent solution for processing big data, including the word count algorithm. HDFS enables the storage and processing of large datasets across multiple nodes in a cluster, while Spark delivers fast and efficient processing capabilities. As a result of these two technologies complement each other to provide a scalable and fault tolerant framework for processing vast amounts of data. Overall, these powerful combinations enables organizations to extract insights from their data efficiently and effectively.
Now let's look into the word count example written in Java, which resides in Spark underscore project app4 directory in this machine. So let's open it for now. So this is the code. As we can see that there are 4 imports which are needed for the code to run. So we are creating a class word count, and we are creating a variable, private variable on named Spark of type Spark session, and we are also having a constructor which takes object of type Spark session. And now moving into this method run, we are having two lines. So what these two lines do is basically it reads the file from this location of HDFS, and what this part of the line does is basically transforms the text file into a column of words. So under the column name word, and what this part of the line does is where the computation takes place, where the word count actually happens here. And in this part of the code we are displayed with the summary of the computation and the results too. And looking at the main part of the code, we are here creating a Spark session object with this Spark builder, and under the app name word count example with 10 nodes, and with the master node residing at this IP address. So we have created a Spark session, and now we are creating an object of type word count, and we are passing the Spark session inside the word count, and we are finally running the word count. After the computation takes place, we finally terminate the code with this spark.stop method. Now let's exit, and let's start the HDFS. Let's look into the directory. Going into the utilities, we'll go under the section browse the file system. In user, so this is the data we have uploaded of file size 104.84 GB. Now let's look a bit more into it. So the total number of blocks that were created are 838. So let's just look into one of the block here, which I have kept open. So let's look into this block, which is of size over 100 MB. So as you can see, the file takes over 30 seconds to load itself, and to load the whole file it takes more than half a day. And it's hard for one to compute the whole file in the local machine itself, and it's highly likely that it might crash also. So that's why we take the advantage of Spark and run this and process this text file in a distributed fashion. Now that will be demonstrated by Zuhair now.
So let's start the HDFS session and also the Spark session. So these are the workers what we are using for this session, and also the total overall connections for this project. So there is a data node running, name node, and also the master node running for the Spark session here. Let's see in the browser. So this is a HDFS, browse the file system, user. Yeah, this is the data what we are using, that will be over 100 GB for this project. These are the 5 worker nodes what we are using for this session, for the first iteration. So this is the code what Prasanna have explained you earlier. This is the path what we have given for the HDFS. So this is the URL for the Spark session and also the name. Let's run the code. It takes a while. First there will be partitions parted. Let's see in the task monitor. So this is the Java code running in the backend, the process.
This is the output of the code. Total executions are done. So this is the output. Overall links with the overall count in the right. So it took 1.2 hours to totally complete this execution. So this is the output for the second execution that has 10 nodes as a workers. So it took 1.4 hours to totally execute this code. So let's run this algorithm with having 20 workers. Let's start the Spark session. So see, there are 20 workers here as executors to execute this piece of code. Like, let's run this. It takes a while. Here you can see the vote count with 20 nodes example. Just started. So I'll see you in a while. So here we can see that it got completed in 1.1 hours, which is not a significant comparison between the 3 iterations we have done so far. So we can also see the DAG representation of the task here. So we can see the upload speed in the third graph from the task monitor. As our device itself acts as a data node, the data should be transferred to the workers. So our findings suggest that a high performance network infrastructure with high bandwidth and low latency can significantly improve the algorithm's performance. To achieve the best possible results, it is recommended to optimize the network infrastructure for high performance and low latency, along with considering other factors such as memory and CPU utilization when working with large datasets in Spark. Thank you.